Member Training, Application Profiles. Now that you know a little bit more about application profiles and what they are, as well as where they fit in with regard to endpoints and clusters, let's look a little bit more in detail at some of the most commonly used application profiles available today. And these are the Home Automation Profile and Smart Energy Profile. I mention these two because these are the two that are already completed and in use by existing devices in the market today. There are other profiles being developed, but those profiles are currently still in a draft format. The Home Automation and Smart Energy Profiles can be found in a published, completed form on the ZigBee.org website for public download by members and non-members of the ZigBee Alliance alike. So, to discuss the profiles in a little bit more detail, the Home Automation Profile is intended as an interface between devices in a home or a small building. So, we'll discuss the security levels in another presentation, but just so you know, the Home Automation Profile is using what it calls the basic ZigBee residential security. So it's a very basic level of security intended to be backwards compatible with the previous ZigBee specification minor revision from 2006. And this just features a network layer encryption, meaning all devices in the network share a common network-wide encryption key. Now, the Home Automation Profile is intended to be useful in either small networks or large networks or anything in between. It's meant to be fairly scalable, but generally these would be fairly small networks that are centralized in some sort of gateway, some kind of home controller device. And to avoid any kind of interference with Wi-Fi activity in the home, the profile specifies that only those channels that don't interact with Wi-Fi bands should be used here. So only a subset of the channels in the 2.4 gigahertz band actually get used here, and those are the ones that are in between the Wi-Fi channel allocations. Examples of clusters used in this profile include from the general functional domain, we have the basic cluster, the on-off cluster, groups capabilities, scenes capabilities. There are measurement and sensing clusters like light sensing, temperature sensing. There's also lighting control in the form of color control. There's HVAC clusters like thermostat control, fan control, pump control, as well as closure commands for shades, window blinds, that sort of thing. And finally, there's a set of security and safety devices known officially as IAS, Intruder Alert Systems. So these would be things like alarms and zone control, motion detectors, that kind of thing. Device types in the HA profile include your basic range extender, which really has no functionality other than to repeat packets to get across the network. There are on and off switches and their corresponding on and off outputs. There are level control switches and their outputs. There are mains outlets, remote controls, and then a configuration tool. In the lighting areas, we have lights, we have switches, dimmers, occupancy sensors, light sensors, and then there are shades and shade controllers. There are heating and cooling devices, as well as thermostats, temperature and pressure and flow sensors, a pump controller, and a pump itself. And then in the IAS area, we have warning devices, we have controllers and indicators, and we have zone devices. Now, by contrast, the Smart Energy Profile is designed less about controlling the individual devices in the home and more about regulating the energy usage in the home. So this is an interface between what's known as the AMI, the Advanced Metering Infrastructure, meaning the smart grid, and the HAN, or HAN, meaning the Home Area Network. So it's a way for the utility to tie energy management at a utility level back to an in-home level. So because there's sensitive data being exchanged here, security is a key concern in this profile, meaning that you take the basic level of security that you had in home automation and you add some extra features. So not only is there network-wide encryption, there's also individual encryption at the APS layer, slightly higher up, meaning that a pair of devices can have their own key on top of the network-wide share key. A trust center is used to facilitate key installation, meaning that there's some centralized device, usually what's called the Energy Service Portal, the key piece that links the utilities grid to your home, typically involved in the meter, and that device is responsible for proxying which devices can attach themselves to the smart energy network and which ones are denied. Furthermore, a key establishment cluster is used to negotiate unique keys between devices. So because there can be these pairwise keys, the Smart Energy Network utilizes a special cluster to facilitate unique key installation. And this is done with what's called ECC, or elliptic curve cryptography, which is a sophisticated encryption algorithm patented by Certicom. Another feature involved in the Smart Energy Profile is the ability to do anonymous messaging. So rather than have a message intended for a specific device, you can send a message not only to devices in your network, but intended for anyone listening on that channel. And this is meant to advertise public information like pricing data for the utility service, as well as any sort of event messages that the utility wants to get out to its customer base. And so this is intended to overcome the fact that smart energy and home automation devices may have very different design needs and therefore may not reside on the same network. So this allows the smart energy devices to relay some of their information out to a home automation network sitting in the same residence without needing some kind of specialized bridge device. In regards to ZigBee versus the ZigBee Pro feature set, smart energy networks are typically ZigBee Pro because they don't have the kinds of backwards compatibility features with the ZigBee 2006 ZigBee feature set, but you can use the ZigBee 2007 devices for the end devices. We'll talk about the node types in a different presentation. The Smart Energy Profile also has the ability to send messages that are larger than the typical 128-byte packet size by using what's called fragmentation, meaning it can break up a large message into a series of smaller messages. And like the Home Automation Profile, Smart Energy does not use any channels that overlap with the Wi-Fi channels. So, clusters used in Smart Energy, we have key establishment, we have pricing to deliver pricing data about the utility service. We have demand response and load control, which is the ability for the utility to regulate the usage of electricity or other utilities in your home in the event that there's a shortage of electricity on the grid, or they simply want you to opt out of using particular services like electricity or gas usage in a time when the resource might be very scarce. And that's generally done in return for some sort of compensation to the user. We have simple metering, which is basic control of accessing the meter usage data so that you can have a display device report information about what's going on in terms of the meter usage. We have a messaging cluster for sending text messages and that sort of thing to a kind of display that I mentioned. And then forthcoming clusters include tunneling, which would be the ability to tunnel more sophisticated legacy metering protocols on top of ZigBee. So this would be something that's still being worked on, as well as prepayment for areas where customers may want to prepay for their utility service. So they're sending payment data up to the utility, and the utility grants them a block of usage. Device types in the SE profile include the ESP, the Energy Service Portal, which is a gateway between the utility and the home, typically subsequent with the meter, but may not be. And this is acting not only as the ZigBee Coordinator, or ZC, but also the Security Trust Center for the network, the TC. And we'll discuss the node types in a bit more detail in another presentation. In the metering devices, we have gas meter, water meter, and electric meter support, with future support for other kinds of meters if they come along. There is an in-premise display defined, which allows you to view the text messages and view the utility usage data. There's a programmable thermostat, which allows the set points of the HVAC system to respond to energy needs from the utility. There's a load control device, which is any device that will respond to load control events from the utility. So this might be a remote disconnect or a smart plug or something like that. We have smart appliances, which are appliances that respond to load control and demand response messages, like a smart washing machine or a smart refrigerator that reduces their usage or changes their usage profile according to the scarcity or pricing of utilities. And then for the prepayment cluster, there's a prepayment terminal, and then the range extender, which, similar to HA, provides only a functionality for relaying messages down the line to another ZigBee device in that network. No clusters supported there other than simply getting onto the network. So now you know a little bit more about the home automation profile and the smart energy profile. Look for a future training module regarding the smart energy profile in more detail, where we talk a little bit more about how the smart energy devices behave on the network, what their responsibilities are, and discuss in more detail what some of the special features of this application profile are. I'm Matt Dibb, and I hope you learned something.